Hello everyone, I am Bharadwaj, a first year undergraduate student in the Data Science and Artificial Intelligence Department in IIT Roorkee. In this video, I am giving a presentation on Wardrobe Manager developed in C++. This project demonstrates fundamental programming concepts and practical application in organizing personal clothing. We will explore the code structure, key functionalities, and how this simple application can bring order to your project. Let's talk about what a wardrobe manager is. Our C++ wardrobe manager is a console-based application designed to help users catalog and manage their clothing items. It allows you to add various clothing items like tops, bottoms, and shoes, categorize items by season and color. You can assign the cloth season and color, display your full wardrobe, filter clothes by season for outfit planning, search for specific items by color. This project serves as a practical example of data structures, functions, and user interactions in C++. I think that's enough for the introduction part. Let's dive into the code. In this code, we include libraries IOStream, vector, string. IOStream for input or output to use cin and cout. Vector for dynamic list, string to use text strings. We are using namespace std, which allows us to write cout instead of std cout. Here we can observe two semicolons in between std and cout. That symbol is called scope resolution operator. It is used to tell the compiler where to find a function, class, or variable. This is the first part of the code. Let's talk about struct. The code data structure is the item struct. The foundation of our order manager is the item structure. This structure defines what information we store for each piece of clothing. Struct contains name, string name, season, color, string color. This simple yet effective structure allows for detailed cataloging and flexible searching of wardrobe items. Each field captures a crucial attribute enabling efficient organization. A struct is nothing but a short form for structure, which is a user-defined data type that lets you group related variables together under one name. Now, vectors for wardrobe categories. To manage our collection of items, we use global vectors, which are dynamic arrays from the C++ standard template library. They have dynamic size. Vectors can grow or shrink as needed, accommodating any number of clothes. Categorization. Separating items into tops, bottoms, and shoes simplifies organization and access. Efficiency. Vectors provide efficient storage and retrieval for our wardrobe data. We make three lists for different categories. Top stores all tops like shirts, t-shirts, sweatshirts, hoodies, etc. Bottoms for pants or skirts. Shoes for shoes like sneakers, boots, etc. Now we have defined the add items function. The add items function is central to populating our wardrobe. It prompts the user for details about each clothing item. Function add item is reusable for tops, bottoms, and shoes. Category tells which list to add to. Type name helps to show messages like top or shoe. GetLine reads input as a string. We then convert it to integer using string. In this function, we take input from the user and colors item name, color, and season. And we use pushback to add new item objects to the specified category vector. And we can add items to any clothing category like tops, bottoms, and shoes. We can observe the code here. At first, we are taking input. It shows a note to the user to guide. Note, first enter the type like shirt, t-shirt, jeans, etc. Then assign a color later. When entering colors, use this format like capital letter first and rest all letters are small. Example in red, R is capital and other ED are in small letters. It helps avoid mistakes like entering all lowercase color names. In this function, we have a for loop. This loop runs n times to add all items and it creates a new item. It asks user to input name. Example shirts, jeans. It asks for the color of the item. It asks for the season. If the user types none, we store it as empty string to represent all season. Pushback add items to the correct vector. And at last we print a confirmation message like if we add two tops, then we print a message like two tops added successfully. Now we have Display items and display full wardrobe functions. The project includes function to view your catalog clothes, either category by category or the entire collection at once. Display items for a single category, example top or bottom, and can apply a season filter. Display full wardrobe function calls display items for all categories to show everything. This function ensures users can easily review their stored wardrobe information. Here you can see the code for the function to display items. It displays all items in a category, and season filter is optional. Here also we have a for loop. It loops through each item in the list. Logic for seasons is if user selects summer, show summer items plus all season items. If he chooses winter, show winter items plus all season items. If none, show only all season items. It prints name, color, and season for the selected clothes. And in the display full wardrobe function, it shows all items in all categories, ignoring seasons, because we want to see our full wardrobe. So you can see every cloth you entered at first into your wardrobe. Now we have display by season function. It is filtering by season. The display by season function is a practical feature allowing users to quickly see what clothes are suitable for a specific season. Its user's choice prompts the user to select summer, winter, or none for all season items. Conditional logic is it intelligently filters items based on the user's input, checking against the item season page. And for outfit plan, simplifies the process of choosing whether appropriate attire. This function highlights the utility of organized data and conditional display. Here we ask the user to pick a season, calls display items for each category with the season filter. Now we have search by color function. Finding specific items is made easy with the search by color function. Leveraging a lambda expression for efficient searching, we ask the user to enter the desired color, example red or blue. Font keeps track if we find any matching mistake. While entering color, we have to stick to the format that the first he have to enter the capital letter and all other letters should be small letters. Like in the case of blue, P should be capital, all other LUE should be small. And we have defined lambda function in this. A certain category lambda iterates through each category, tops, bottom, and shoes. A lambda function is a simply short unnamed function. A function you create on the spot, usually inside another function. It's also called an anonymous function because it has no name. And at last, if an item's color matches the query, its details are printed. A flag indicates if any item is found. If no match, prints a not found message. This feature demonstrates basic search algorithms and the use of modern C++ features like lambdas for concise code. Here we can observe the code. In this code, first we have asked the user to enter the color to search, and at last, if no color is found, we have printed a message that no clothes found with color. Now at last, main function and user interface. The main function orchestrates the entire application, presenting a menu-driven interface to the user. Main function contains menu display. A loop continuously displays options like adding items, viewing the wardrobe, filtering, and searching. And second, user choice. Scene captures the user selection, which is then handled by a switch statement. It treats choice as string and converts to integer to avoid input problem. And each menu option corresponds to a specific function call executing the desired action. And at last, exit condition. Here we can observe a do-while loop. The do-while loop continues until the user chooses to exit, ensuring a graceful termination. This structure provides a clear, intuitive way for users to interact with the wardrobe manager. Here we can observe the code for the main function. In this main function, there is a do while loop and switch cases. And if the user chooses to exit, then we will print a message and tell him goodbye. Now let's take a look on the entire code. At first, we defined a struct named item and some vectors. We defined add items function to add items. It contains a for loop and another function named display items. Another function named display full wardrobe to display all the clothes in your wardrobe. Display by season function to display clothes by season. Search by color function to search clothes according to their color. And main function, it contains a do while loop and switch cases. Now let's take a look on output. Let's try to take an example. First, I want to add tops, so I will enter 1. I want to add 3 tops, so I will enter 3. Here we can observe a note saying that first enter the type like shirt, t-shirt, jeans, etc. Then assign a color later. This will be useful to search a cloth according to the color. I want to add a shirt, so I will type shirt. Now I have to enter the color of shirt. And there is also another note saying that when entering colors, use this format. Capital first letter, rest small. Example, in pink, P is capital and I in K are small. So I will strictly follow the format. and I will enter the color. Here we have to assign a season for this cloth. This is a white shirt. I want to assign summer season for this white shirt. So I will enter summer and I will repeat the same process. I have entered three tops. One is white shirt and I have assigned summer season. One is black sweatshirt. I have assigned winter season. And the other is blue t-shirt. And I haven't assigned a season to that blue t-shirt. Now I want to add bottom. So I will enter two. I want to add two bottoms. Now I will enter the first bottom. I will assign a color to that bottom. And now I am assigning season. I am repeating the same process for the second bottom. I have entered black jeans for all seasons and blue baggy cargos for winter season. Now I will add shoes. I have entered three shoes: white sneakers, black Chelsea boots, and color block chunky sneakers, and all of them for every season. Now I want to see how many clothes are there in my wardrobe. So I will enter fourth option. We can observe that we have got full wardrobe. In tops, white shirt for summer, black sweatshirt for winter, blue t-shirt for all seasons, black jeans for all seasons, baggy cargos for winter, white sneakers for all seasons, black Chelsea boots for all seasons, and color block chunky sneakers also for all seasons. Now I want to display my clothes according to the season, so I will choose fifth option. I want to see what are the clothes I can wear summer. So I will enter summer. You can observe that I can wear white shirt, blue t-shirt, black jeans, white sneakers, black Chelsea boots, and color block chunky sneakers in summer. Now I want to see what are the clothes I can wear in winter. We can observe that I can wear black sweatshirt, blue t-shirt, black jeans, blue baggy cargos, white sneakers, black Chelsea boots, and color block chunky sneakers in winter. Now I want to see what are the clothes I can wear in any season. I can wear blue t-shirt, black jeans, white sneakers, black Chelsea boots, and color block chunky sneakers in any season. Now I want to search clothes by color. So I will enter sixth option. Here also I have to strictly follow the format. So I am following it. In blue color I have blue t-shirt and blue baggy cargos. Now I want to see white color clothes in my wardrobe, so I will again choose sixth option. I have white shirt and white sneakers. Now at last I chose what the outfit I want to wear today. So I am exiting. So I am entering seventh option. It is shown that exiting goodbye. So the conclusion is this C++ Wardrobe Manager project effectively demonstrates foundational programming concepts such as data structures, using structure and vector, functions, modularizing code for reusability, user input or output, interacting with the console, control flow, implementing do-while loops and switch statements, etc. It's a solid basis for understanding how to build practical applications with C++. Thank you.